going to record now. Let's turn to page 26 of your notes and let's look at the rule for negative exponents. Okay? So the rule says, we talked about I had a diagram on the board. I think we were talking about 5 cubes last week. Okay, so I had this scenario 5 cubed, which is 125, 5 squared, which is 25, 5 to the first power, 5 to the 0 power is 1. Now, as we keep going, as far as our exponents decreasing, what's going to take place? If we're dividing by 5 each time here, then if I divide 1 by 5, I get this here. If I divide 1/5 by 5 again, we have 1 over 25. If I divide 1/25 by 5, we get 1 over 125. What I want you to look at here is, look what happens. Look at our solution when our exponent is positive. We get 120, we have 5 to the positive 3, we have 125. But what happens when our exponent is negative? It reverses. It reciprocates. Okay? So, meaning the reciprocal. So, what the rule says, that to make a negative exponent positive, you're going to keep, first of all, take the reciprocal, that's number 1, of that expression that is raised to a power where that exponent is negative. Take the reciprocal of that expression. Then 2, keep the base the same. And 3, once you take the reciprocal, the exponent becomes positive. And you can have a negative exponent in the denominator. I need you to understand, when I'm talking about reciprocal, if it's negative, if that expression is negative in the denominator, to make it positive, you take it to the numerator. Reciprocal, fraction, numerator, denominator. It can't go no other places than up or down. Yeah, I don't care about left or right, but as long as I'm saying up or down, because that's what we're saying about reciprocal. We're not saying we move to the left, we're not moving to the right, but numerator, denominator. Take the reciprocal. And this is what the definition says. If A is a non-zero real number and N is an integer, then A to the negative n power becomes 1 over A to the positive n. In words, a negative exponent indicates the reciprocal of the base. Keep the base the same. You're not going to change the base. You're going to keep the same base. Keep the same base. So let's take a look at some of the some examples here. Let's make this example 4. Example 4. We have here 7 to the negative 2 power. Now, even though this is not written as a fraction, because if I'm talking about reciprocal, if the number is in a fraction, we're going to make it into a fraction. Okay? So, what the rule says, we're going to take the reciprocal of 7 to the negative 2, where the 7 is going to go to the denominator. We keep the base the same, but the exponent becomes positive. And what's in the numerator is 1. Okay? And then we have here 1 over 49. If you want to, if that question is not written originally as a fraction, you could have put this 7 to the negative 2 power as a fraction put over 1. And so that you can see that that 1 is going to go to the numerator. Okay? Let's do another one. We have here 5x to the negative 4 power. You're saying 5 times x to the negative 4. So this one now is just not one expression. Okay? You have two factors, the 5 and the x to the negative 4. Okay? Now, we want to make this into a fraction. We can say over 1. I want you to see this. Now, not every factor we will take the reciprocal to. Okay? In order for me to take the reciprocal of this 5 and the x at the same time, then parentheses will have to be placed around the 5 and the x. What is raised to the negative 4 power here is just the base x. The 5, if I wanted that exponent to be negative, it would have been there. But when there's no exponent here, it's understood to be what? 1, positive 1. So we're only taking the reciprocal of expressions that's raised to a negative power. So this x to the negative 4 is going to go to the denominator. Your 5 is going to stay where it belongs. Any expression or any factor that has a base raised to a positive exponent, you keep it. You don't change it. Okay? Meaning you don't take the reciprocal of it. Okay? And I'll give you an example. Another example. We have here our answer, 5 over x to the positive 4 power. Okay. Here we go. We have y to the negative 10 over y to the 3rd power. So this is the question, and this is how I understand it, how I made it make sense to me. I ask myself, do I see any expression, any factor where the exponent is positive? Yes or no? Yes, denominator. So that y cubed is going to stay there. When the exponent is positive, there's no need for us to do any kind of reciprocating. But then I say, okay, do I have any expressions where I have an exponent that is negative? Yes. This y to the negative 10 is going to go to the denominator. In the numerator, it's blank, but it's understood to be what? 1. A 1. So we have 1 over, then you have y cubed times y to the 10th, which is y to the 3 plus 10. We have 1 over y to the 13th power. Okay, here's a good one. We have here 10 x to the negative 8, y to the positive 5, all over 20 x y to the negative 5. All right, so here's my question. Look at the numerator. Which factors will stay because the exponents are positive? And what else? No. In the numerator, just the numerator. 10 and the y to the 5th.
Well, when you could reduce that down?
We will. Just hold off. Just hold on for a second. We will reduce. Okay? All right, so if in the numerator, the 10 and the y to the 5th is going to stay in the numerator, where would the base x go?
To the denominator.
To the denominator. So we're going to put it there. Okay? Now, in our denominator, which factors will stay? The 20 and the not the y, but the x. And then what will go to the numerator? Y to the negative 5. The base y stays the same, but the exponent becomes positive. Now, let's go ahead and do some reducing of 10 and 20. We're going to reduce it. Okay? So 10 divides into 10 once. 10 divides into 20 twice. And what are we going to do to the exponents to base y? Add? Yes. Our denominator 2x to the 9th power. So our solution, y to the 10th all over 2x to the 9th power. Question?
You don't put the 1 over 2 in it?
Don't say it again.
The 1 over 2, the 10 and 20 reduces to 1/2.
You can put the one there,
Okay.
but
Why?
we can, but in my math lab is going to mark it wrong because it's an understood 1 in front of the y to the 5th if we put it there or not.
I didn't see the 2, that's why I was confused. Now I see it.
Okay.
Never mind.
Okay. Yes.
That's what I meant, 1 over 2. That was
The last little bit of the exponents, the power rule. Okay, and then we'll put like I said, we'll do a lot of examples. I have more than enough for you. Power rule that says, this is example 5. Your power rule. It says you have a base raised to a power, then that is being raised to a power, which is called power to a power rule. It says to multiply the exponents. So we have y to the 16th power. Let's do another one. Here we have x to the negative 5, all raised to the negative 7 power. Now, before you try to take the reciprocal of this, let's look at it. It's power to a power. What's going to happen to the negatives? They're going to become a positive. So we're saying y to the negative 5 times negative 7, or x to the negative 5 times negative 7, and we have x to the 35th power. The second rule, the power rule for products. And what this is saying, okay? We have x and y, and that is being raised to the 3rd power. Okay? We have a product. Product means multiplication, x times y, being raised to a power. We're going to take this exponent of 3 and we're going to distribute this exponent of 3 to each factor as an exponent to that power. You're saying x cubed times y cubed. Okay? Let's do one that has a number in it. We have here 3 g to the 4th power, and then all of that is cubed. Okay? So we're saying 3 cubed times g to the 4th cubed, 27 g to the 12th. Okay? All right, because that will become a power to a power, so we're using that power to a power rule as well. All right, let's look at the third rule. Power rule for fractions. This is similar to power rule for a product, and normally sometimes the textbooks say power rule for quotients, meaning fractions. But same thing applies. We have here, let's say y over z, and let's say that is raised to the fourth power. We're going to apply that same rule as we did with example C, but it's just a quotient. We're going to take the exponent of 4, and we're going to distribute this as an exponent to the numerator and to the denominator. As an exponent, so y to the 4th all over z to the 4th. We have here the quantity of 4m to the 5th all over n cubed, and then all of that is being raised to the second power. So actually we're using all three of these power rules. Just think of your order of operation. We still have to get rid of the parentheses. How are we going to do that? Take this 2 and distribute to every factor we see inside the parentheses. So we have that power rule for a product, then we have the power rule for the fraction, and power to a power. So we're using all three of these rules here. Show it. Just, if you have to draw an arrow, do that. To say that you're going to, and let me explain something that I've seen in previous work. Don't just distribute the 2 because it's closest to this m to the 5th, or just because it's another exponent. It says you distribute to every factor, even when the base happens to be a number, which is the 4. Okay? So you're saying 4 squared, m to the 5th squared, all over n cubed squared. So we have 16 m to the 10th over n to the 6th. And there we go.